Inside the tail of a Royal Air Force bomber identified as P1344, conservators found a second serial number, L6012. It was not a partially erased version of the aircraft's identity. It was not a clerical error, and it had not been added after the crash. The number belonged to a different aircraft. L6012 had been built as a Handley Page Hereford, a close relative of the Hampden, but one designed around Napier Dagger engines. P1344, by contrast, was a Hampden, powered by Bristol Pegasus radial engines. Yet the metal carrying the Hereford number had unquestionably formed part of P1344 when it made its final flight. That contradiction turned a difficult restoration into an investigation. Before the museum could decide how to reconstruct the aircraft, it first had to establish what the wreckage represented. P1344 was not simply a damaged example of a standard production bomber. It was an aircraft that had already been altered, repaired, and returned to service before being sent on a hazardous mission to northern Russia. Its surviving structure contained several histories at once. Some parts recorded its manufacture before the war. Others recorded accidents and repairs carried out during service. Bullet holes and fire damage preserved evidence of its final battle. Crushed frames and torn skins showed what happened when the aircraft came down in a forest. Corrosion and missing material recorded almost 50 years of exposure inside the Arctic Circle. By the time the wreck arrived in Britain, those layers had become physically entangled. The question was no longer simply how to make a Hampden look complete. It was how to preserve the identity of one particular Hampden without erasing the events that had transformed it. Handley Page Hampden P1344 was built at the company's Cricklewood factory in London and entered RAF service in December 1939. Its first posting was to No. 14 Operational Training Unit, where it was used for training rather than combat operations. As the Hampden began to disappear from its original frontline bombing role, selected aircraft were converted into torpedo bombers and redesignated TB Mark Is. P1344 was one of them. After conversion, it joined No. 144 Squadron at RAF Lukers under Coastal Command. The new role required crews to learn a very different kind of attack. Instead of releasing bombs from altitude against targets on land, they would approach enemy shipping at low level and launch a torpedo into the water. RAF Museum records note that crews practiced with drain pipes filled with sand to simulate the weight and handling of the new weapon. P1344 flew one operational sortie towards Christiansand, but the target was not located and its torpedo was not released. Its next major assignment would take it much farther from Britain. In September 1942, Allied planners were preparing to protect Arctic convoy PQ-18. The Arctic convoys carried weapons, vehicles, fuel, and other supplies from Britain and North America to the Soviet Union. Their route passed through waters exposed to German submarines, aircraft, and surface warships based in occupied Norway. Among the most feared threats was the battleship Tirpitz. The possibility that Tirpitz or other heavy German ships might sortie against PQ-18 led to the creation of an air component operating temporarily from Soviet territory. Reconnaissance aircraft would watch German anchorages. Catalina flying boats would search the surrounding seas. Hampden torpedo bombers would be available to attack any major surface force approaching the convoy. The Hampden element came from No. 144 Squadron RAF and No. 455 Squadron Royal Australian Air Force. No. 455 Squadron had also transferred from Bomber Command to Coastal Command earlier in 1942 and retrained for torpedo operations. Together, the two squadrons formed the Maritime Strike Force being sent to northern Russia. 32 Hampdens gathered at Sombra in the Shetland Islands for the journey east. This was not intended to be a combat sortie. The aircraft carried no torpedoes on the ferry flight. Much of the heavy equipment and most of the ground personnel traveled separately by sea. But the flight itself was dangerous enough. The Hampdens had to cross a vast distance through unstable weather, over sea, high ground, and areas controlled or watched by the enemy. Navigation errors, icing, fuel problems, or an encounter with German forces could be fatal. The aircraft were operating close to the limits imposed by their fuel and the route. Each Hampden also carried an additional member of the ground staff. These technicians would be needed in Russia to maintain, refuel, and arm the aircraft after their arrival. Adding another man to a Hampden, however, was not a minor matter. The aircraft had been designed around a crew of 4. Its forward fuselage was unusually narrow and deep. Crew members occupied separate stations along the length of the aircraft, rather than working together inside one open compartment. The pilot sat high in the forward fuselage. The navigator worked in the nose, below and ahead of him. The wireless operator and gunners occupied positions farther aft. In normal flight, this arrangement was restrictive. In an emergency, it could become a trap. The internal passages were difficult to move through, particularly when crew members wore flying clothing, parachutes, and other equipment. A man in the nose could not simply stand, turn, and walk towards an exit. His ability to escape depended on the attitude of the aircraft, the damage around him, and the time available. For P1344's final flight, the normal 4-man crew was joined by Corporal George Shepherd, an engine fitter. Pilot Officer Esmond Perry was the captain and pilot. Flight Sergeant Gordon Miller of the Royal Canadian Air Force served as navigator. Sergeant James Robertson was the wireless operator and an air gunner. Sergeant Daniel Garrity occupied another defensive position. The aircraft used the squadron code PL-K and was known as K for Kitty. On the night of 4-5 September 1942, the Hampdens departed Sombra. Even under good conditions, the crossing demanded hours of sustained navigation. Crews had to manage fuel carefully while monitoring weather, heading, and position over terrain that offered few familiar reference points. The danger became apparent across the force. By 5 September, 24 of the 32 Hampdens had reached Vienga safely. Others were lost, forced down, damaged, or diverted after icing, fuel shortages, navigational errors, and encounters with enemy-controlled territory. P1344 began to experience icing. As the temperature fell, ice accumulated on the airframe, and the aircraft became increasingly difficult to keep at the altitude needed to cross the higher ground ahead. Perry could not continue on the intended route without risking a collision with the terrain. He changed course in search of lower ground. The decision removed one immediate danger, but brought P1344 towards another. The revised route carried the aircraft too close to the German airfield at Petsamo in northern Finland. The Hampden came under fire from the ground. Then, 2 Messerschmitt Bf-109 fighters took off to intercept it. Against the German fighters, P1344 was at a severe disadvantage. It was carrying an additional passenger, nearing the end of a long flight, and already dealing with icing and an enforced route change. It could defend itself, but it could not match the speed or maneuverability of the interceptors. Inside the narrow fuselage, each crew member could see only part of what was happening. Miller passed information to Perry from the nose, while Robertson and Garrity attempted to defend the aircraft from their positions farther aft. Shepherd, carried as a technician rather than a combat crewman, had little control over the unfolding situation. The attack did not last long. Robertson and Garrity were killed during the aerial battle. Perry eventually reported that he was losing control and would attempt to put the aircraft down. P1344 descended towards wooded terrain on the Kola Peninsula. A forced landing in a damaged bomber was not a controlled arrival in the normal sense. Perry could only try to reduce the violence of the impact while avoiding obstacles that appeared at the last moment. The Hampden struck the forest and came to rest in German-controlled territory. Perry and Shepherd survived. Miller did not. Trapped in the Hampden's nose, he was unable to escape before the impact and was killed during the crash landing. Of the 5 men who had left Sombra aboard P1344, 3 were dead. Perry and Shepherd were captured and spent the remainder of the war as prisoners of war. For P1344, the operational story ended in the forest. Its physical story continued. The crash bent frames, tore skins, and opened joints before the weather began its work. Rain and seasonal moisture entered the damaged airframe. Corrosion developed across surfaces and inside connections. Repeated freezing and thawing weakened unsupported sections until the aircraft no longer existed as one stable object. It had become a wreck site. That distinction mattered when the remains were recovered. A complete aircraft can usually be handled through known load-bearing points. A wreck may no longer be strong enough to use them safely. Sections that appear connected may be held together by little more than damaged fasteners, corroded skin, or the surrounding soil. Before anything could be moved, each section had to be assessed, recorded, and supported. The order in which components were lifted could determine whether adjacent material survived or tore apart. P1344 remained inside the Arctic Circle for almost half a century. It was recovered from northern Russia in 1991 and transported to Britain through Rotterdam. The Royal Air Force Museum acquired the wreckage in 1992. Recovery had removed it from continued exposure, but conservation had only begun. Every surviving component needed to be photographed, identified, and examined. Cleaning might reveal a manufacturing mark, an original paint layer, or evidence of an earlier repair. A line of rivets could show that a panel had been replaced. Bullet holes, scorched paint, and damaged wiring could preserve evidence of the final battle. In conservation, damage is not merely a defect, it is also information. Work began at the RAF Museum's Restoration Center at Cardington and later continued at the Michael Beetham Conservation Center at Cosford. The rear fuselage became an early focus because it offered the best opportunity to preserve a substantial amount of original material. Preservation did not mean leaving every surface untouched. Corrosion had to be stabilized, weak joints repaired, and missing material addressed where its absence threatened adjacent structure. The aim was not to return the metal to the condition in which it had left the factory. That was impossible. The aim was to prevent further deterioration while retaining as much evidence as the structure could safely carry. During examination of the rear structure, the number L6012 became central to the aircraft's interpretation. The primary identity of the wreck was P1344. Its service history, surviving components, and documentation all supported that conclusion. But the tail boom carried the identity of a Hereford. The museum's aircraft was clearly not a Hereford as a whole. The Hampden and Hereford shared the same basic airframe concept, but their engine installations were different. P1344's radial engine configuration identified it as a Hampden. Museum research later established how the Hereford number had entered the structure. Before its transfer to Russia, P1344 had suffered serious damage when an Avro Anson taxied into its tail boom. A usable tail structure from Hereford L6012 was fitted to return the Hampden to service. Evidence of other major repair work suggests that P1344's configuration continued to evolve during its operational life. The replacement tail did not make P1344 less authentic. It made the aircraft more specific. A perfectly standard Hampden reconstructed from production drawings could represent the type. The Hereford tail represented the service life of P1344 itself. It showed that the aircraft had been damaged, repaired, and returned to use. It also showed that an aircraft's official serial number did not necessarily describe the origin of every major component fitted to it. For the museum, L6012 could not simply be painted over or dismissed as an error. It was part of the evidence. The tail boom, however, presented a serious conservation problem. Its history made it worth preserving, but its condition made it difficult to reuse. To restore the original structure to the strength and geometry required for installation, the team would have had to remove or replace a substantial amount of surviving material. The more aggressively it was restored, the less of the historic tail boom might remain. The museum, therefore, manufactured a replacement tail boom for the reconstructed fuselage and preserved the original L6012 structure separately. The new component restored the outline and continuity of the aircraft. The original retained its serial number, wartime repair history, and crash damage. The two structures now serve different purposes. The replacement allows visitors to understand the form of the Hampden. The original allows them to examine material that actually flew on P1344 during its final mission. A similar tension shaped the treatment of the fuselage. The museum initially considered displaying P1344 in two contrasting states. One side reconstructed to show the aircraft in service, the other left closer to the condition in which the wreck had been recovered. As an interpretive idea, the contrast was powerful. A visitor could have seen the bomber as an operational machine on one side and the consequences of combat, impact, and decades of exposure on the other. In practice, the approach created difficult structural and conservation problems. The museum abandoned the split presentation and moved towards reconstructing the complete fuselage. That decision did not mean all evidence of damage would disappear. Several bullet holes were preserved. Evidence of a small fire in the rear fuselage, including scorched paint and damage to part of the wiring, was conserved rather than replaced with material made to appear new. The aircraft needed enough reconstruction to recover its form, but enough visible evidence to show that the form had once been broken. The forward fuselage required the greatest amount of new manufacture. Too little of the original nose and cockpit structure remained intact for conventional repair. Much of the framework had to be recreated. Yet the industrial system that had originally produced the Hampden no longer existed. There were no surviving production lines, no complete set of assembly jigs, and no workforce carrying an unbroken memory of the original construction sequence. The museum did possess original Handley Page pre-production drawings from the late 1930s. Those drawings supplied dimensions and geometry, but they did not describe every stage of assembly. Knowing where a frame ends up is not the same as knowing when it must be installed. A fitting placed too early can block access. A skin panel attached too soon can make it impossible to install controls or equipment behind it. Technicians had to reconstruct not only the aircraft, but the logic of its manufacture. New formers defined the cross-section of the fuselage. Frames, seat mountings, instrument panel structures, and windscreen supports were made and fitted in the correct relationship. Measurements were taken from the surviving wreckage wherever possible. Original castings and components were restored and incorporated when their condition allowed. Other suitable equipment came from the museum's stored collection. The process required repeated checking. A new part could match a drawing and still fail to align with surviving wartime material. Original aircraft contained production tolerances, workshop adjustments, repairs, and modifications accumulated during service. The drawings showed what Handley Page intended. The wreckage showed what had actually existed on P1344. Where the two disagreed, the team had to determine whether the difference came from damage, manufacturing variation, or a genuine wartime alteration. This is one reason aircraft restoration can take decades. The time is not spent merely cutting and riveting metal. It is spent deciding what each piece means and how much intervention it can survive. The rear fuselage remained largely original. The forward fuselage became primarily a modern reconstruction, incorporating selected original components. The replacement tailboom recreated a form that the original could no longer safely provide. The tailplane followed another balance, incorporating approximately 25% original structure. Percentages can be useful, but they do not measure historical value by themselves. A small original fitting may carry a serial number that resolves the identity of an entire section. A new frame may contain no wartime material but be essential for supporting many original components. What matters is whether the boundary between surviving and recreated material is honestly documented. The wings created another practical limit. They were recovered and remain in the RAF Museum's collection, but they were not included in the completed fuselage project. Restoring both would demand extensive workshop space, skilled labor, and additional resources. Displaying a Hampden with a wingspan of almost 70 feet would also require a gallery capable of accommodating the aircraft, while allowing visitors to move safely around it. The museum therefore concentrated on the fuselage. The wings remain in storage and could become the subject of future work if the necessary resources and space are available. Their absence does not make the project a failure. It reveals the limits under which museums work. Technical possibility is only one part of a restoration. Funding, staff, workshop capacity, conservation risk, and display space also shape what can be completed. P1344's final form emerged from a long sequence of such decisions. After almost 30 years of work, its 4 fuselage sections were assembled and painted in the colors and markings of No. 144 Squadron. The project produced the first complete Hampden fuselage seen in Britain since the mid-1940s. From a distance, the result appears coherent. The narrow nose, cockpit, central structure, rear fuselage, and twin-fin tail once again form the recognizable outline of a Hampden. Up close, the aircraft remains divided by history. The rear fuselage contains much of the material that survived the final flight and the decades in Russia. The forward fuselage records the modern effort to recover a shape the crash had almost completely destroyed. The new tail boom occupies the position once held by L6012, while the damaged original survives separately. The tailplane combines original and replicated structure. Bullet holes and scorched material preserve selected evidence of combat. On 30 June 2025, the completed fuselage left Cosford for the RAF Museum's London site, where it would go on public display for the first time. The move marked another change in the aircraft's purpose. In 1939, P1344 had been a newly manufactured military machine. In 1942, it became a torpedo bomber sent across northern Europe with 5 men aboard. After the crash, it became a wreck in a remote forest. After recovery, it became evidence. During conservation, it became a collection of decisions. Now, it is a museum object. The aircraft seen in London is not identical to the one that left Sombra in September 1942. Too much had been destroyed for that to be possible. Its authenticity lies instead in the careful separation of what survived, what was repaired, and what had to be recreated. It lies in preserving the Hereford tail boom instead of consuming it during restoration. It lies in retaining selected bullet holes and scorched material rather than smoothing away every mark. It lies in acknowledging that much of the forward fuselage is new and that the wings remain unrestored. Most importantly, the reconstruction reconnects the aircraft with the 5 people who occupied its confined interior during the final flight. Esmond Perry brought the damaged aircraft down and survived captivity. George Shepard had boarded as an engine fitter rather than a normal member of the combat crew and also survived to become a prisoner of war. James Robertson and Daniel Garrity were killed while the aircraft was under attack. Gordon Miller remained trapped in the Hampden's nose and died during the crash landing. The restored crew positions make their situation easier to understand. The narrowness of the fuselage is no longer merely a technical description. Standing beside the aircraft, a visitor can see how little room existed between the structure, equipment, and men. The reconstructed frames and skins show where Perry sat while trying to retain control, how isolated Miller was in the nose, and why carrying a 5th man was such an uncomfortable necessity. The replacement structure, therefore, does more than complete an outline. It recreates the physical relationships that shaped the crew's experience. P1344 is neither an untouched wreck nor a newly manufactured replica. It is a layered object assembled from surviving material, repaired components, replacement structure, documentary research, and modern craftsmanship. The number P1344 identifies the aircraft. The number L6012 reveals one of the events that shaped it. The damage records its final mission. The reconstruction records the effort to prevent that mission from being forgotten. A museum cannot return P1344 to September 1942. It cannot restore the 3 men who died, undo the captivity of the 2 who survived, or make every fragment strong again. What it can do is preserve enough evidence to make their history tangible. The Hampden can no longer carry a torpedo, cross the Arctic, or defend a convoy, but it can still perform one final duty. It can bring together the story of an aircraft built in London, repaired with the tail of another machine, sent across northern Europe, attacked over Petsamo, abandoned in the Arctic, and reconstructed decades later from the edge of disappearance. And through that aircraft, it can preserve the memory of the 5 men who made its final flight.